Everybody, let's see how the size of rock particles affects how much water an aquifer can hold. The supplies we have is a cup full of rocks with big spaces in between the rock particles, a cup of pebbles with smaller spaces in between the particles, sand with hardly any spaces in between the particles, and a cup of clay. And I've got equal sized cups of red water so we can see it better, and we're going to pour the water into the containers with rock material and see how much each one holds based on its particle size. Okay, so the rocks held about half a cup of water. And now the pebbles held a little bit less, maybe like 3/4 of a cup, or 1/4 of a cup of water. Let's try the sand now. Ooh, and it doesn't go down as easy. I have to wait. You can see it bubbling away. I think it's almost saturated. The water's infiltrating down, working its way in between the particles. I think there it's full. Now the sand held just a little bit, about the same as the pebbles. Now let's try the clay. I'm going to predict what's going to happen here. Oh, made a mess. It didn't hold any. So, what can you infer about the size of the spaces between rocks and how much water an aquifer can hold? In order to be a good aquifer, rocks need to be both porous and have good permeability. Porosity just means how many spaces or holes are there in the rock that the water can be in. But if the holes aren't connected, it doesn't matter how many holes there are because the water can't move from one space to the next, which is permeability. Aquifers need to have good permeability so that the water can move down into the rocks, hold there for days or up to thousands of years, and then people can drill wells into that aquifer and move the water from the ground up to the surface. So aquifers need to have high porosity and high permeability, but the most important one is permeability.